sketch y equals cos x in the domain minus pi less than or equal to x less than or equal to 2 pi. Alright? Now, a hard part of this is realising what is the... in a way, if you really wanted, you could convert it into degrees, couldn't you? How'd you do that? What's minus pi? And what's 2 pi? Is that okay with you guys? Now what sort of step would you use there? Maybe go up in 30s? See whatever will fit, okay? So you go to your calculator. I have it in degree mode. And I go, no bother. Menu. Will you all do this because I'm going to need some points off you in a second. 3 cos x and then start at minus 180 and at 540 and hopefully going up in 30s they'll be able to handle it, otherwise I'll go up in 45s. So is everybody happy enough with the did everybody get the same table I got? You get the same table? Alright. Here's what we're going to do. We're going to keep this. Now, we only had to go as high as 1, don't we? So, 0.51. And we only had to go as low as, what do we have to do? We only have to go as low as the same thing. So what's it? Minus 0.5. Minus 1. This should be bread and butter to you, lads. Reasonably easy stuff. Alright, now what's the other thing we're doing here? We have to go from minus 180, don't we? So what I'm going to do is I'm going to make every minus 180 would require 9 of these. 540 is 18 points. Alright, every block is worth 30, is that okay? So essentially that's 90, 180, 270, 360. Is that right? What's that, 450? Wait a second. No, sorry, I only had to go up to 360. Sorry, my fault. Don't know where I was getting that into my head. And Durham's all the way to minus 180, isn't it? Minus 90, minus 180. Okay. What's minus 180? What is it? What? Minus 1. Okay. What's minus 150? So in between 0.8 and 0.9. Next one, what's minus 30? Oh, sorry, minus 120, I mean. Yeah. Minus 90? Okay. Minus 60? A half? Minus 30? Yeah. 0? Okay, next one after that is, I think we have it now. It's symmetrical, isn't it? Is 120 a half? Minus a half? Yeah. 150 is 0.86, 180 is 1, and then keep going again. See the way it gets symmetrical after a while? Where you just balance it up. That's when it gets easy. There we go. Redrawn on this is going to be difficult though, but you'll get the gist. Now, we cool with that? Okay. Two things I want to run over with you. Firstly, I want to talk about something called range. Does anybody know what the range of this graph is? It's the bottom y value compared to the top y value. So what do you think it is? Minus 1 all the way up to 1. Now, does anybody know what I mean by the word period? Alright? It means when do you encounter the same part. So imagine you're this yellow dot here. See the yellow dot? At what other stage are you at the bottom of the graph and on your way up? Does anybody see it? What other stages does that happen at? Now, what I'm going to ask you is, what is the difference between minus 180 and plus 180? 360. That means the period is 360. The period can be taken from anywhere. Give you another example. At what point are you at a value of 0 and on your way up? Where else does that happen? And what's the difference between 270 and minus 90? 360. Go again. At what point are you at the top of the graph and about to go down? So the gap is always 360 for this graph only. Okay? Anything with sine or anything with tan x, anything with anything with just x, sine x or cos x. Now lads, the other thing that you're going to notice here is the following. It asks for the equivalence of the maximum point of the curve. I suppose the maximum point of the curve will be this part here, wouldn't it? 0, 1 is the highest point, isn't it? Or you could also arguably say 360 and 1 is the other maximum point. Is that okay? There's more than one of them. I know the solution's a bit odd there. I'm looking at it here. It doesn't make sense to me. Alright, let's move on and do some of the other stuff now. The interesting thing to notice about tan. Once again, I'm just going to change these to degrees. Is that okay with you guys? 0, 90, what is it? 180 and 270. Does anybody know what tan is again? Would everybody agree that tan is the value of the opposite side over the adjacent? So if I said 5 over 2, what would happen there? What would tan x be? The value of tan x would be 2.5. Is that right? Which would equate to an angle of, for argument's sake, shift tan inverse 2.5. Angle of 68 degrees. Everybody see that? And look, if I draw 2.5, draw it and bring it down. Do you see the way the answer is somewhere between 0 to 90? Closer to 90, right? That would be your answer of 68.19. Liam, do you notice there's another answer? And what is the other answer, do you reckon? Close to 270, isn't it? Now this is where Anto stole the car comes in, ASTC. Alright? Now what did we say about when is tan positive, lads? Huh? A, S, T and C. The answer for all is 68.19 degrees. What other quadrant do we want to know? Where? T. We want to know T. And what's the rule for quadrant 3? I gave us all the rules. No, it's 180 plus R. So what is 180 plus 68.19? $248.19. Is that roughly what we're expecting this to be? That point there? Close to 270, wasn't it? Okay. Now, for argument's sake, let's change this around. This time I'm going to say it's minus 2.5. Does anyone in class know where roughly the answer will be using the graph? Where's minus 2.5? What do you reckon? above 90, in between 90 and 180, closer to 90. Would that make sense? Where your tan graph is minus 2.5, yeah? And here's what we're going to do. We're going to tan inverse 2.5 again. So tan inverse 2.5. I believe we already have the answer. You ignore the fact it's minus and just tan inverse as you would normally. Everybody gets 68.19. Is that clear with you guys? Now, next thing I'm going to want you to do is the following. What I want you to do next is, what rule do we use for when tan is negative? Which quadrant do you think it happens in? When is tan negative? S and? We want it wet the first time. This is the first time it's negative, isn't it? So that'll be S before C. So what's the rule for S? So 180 minus R, which is? So what you get? 111.81. Is that alright? And lads, that's what we're expecting, an answer close to 90. Now, the interesting thing to notice about tan graphs, okay? So if you throw tan into your calculator, everybody get your calculator out? Alright? And you'll need to know this going forward. You draw mode, table function, and you'll do tan x. Okay, and you'll go from, where's it, 0 to 270 degrees. 270. Do step 30 again. Okay. What you notice about 90 degrees? Error. What you notice about 270 degrees? Error. I'm going to show you why. Ready for this? Imagine I keep this at a radius of 5. See my triangle? I keep it at a radius of 5. Oh, sorry. For argument's sake, it's 5, alright? And that's 2 and some other value. Okay. What happens, generally speaking, when I go, what happens when I move it up like that? What will happen to the value for 2? What happens to the value for 2? Has everybody agreed that it gets smaller? Is everybody alright with that? And has everybody agreed that the opposite gets bigger? Now what happens if I get closer to 90 degrees? When I make it really, really, really small? So what happens when I go nearly close to vertical? Alright? And what I'm trying to do here is, what happens to the adjacent value? Anybody? It gets smaller again, doesn't it? And what happens when I go all the way to 90 degrees? What will happen to the adjacent value? 0. It's gone. And how did we say we calculate tan again? Opposite over. But if the adjacent value is 0, what happens in the calculator? Can you divide anything by 0? Maths error. And that is why you have a maths error at 270 and you have a maths error at 90. Is that okay? It's because it's either going straight up or straight down and the adjacent doesn't exist. Is that alright? So you all get that, or do you want me to go again? Or you sure? Alright. So, how do I know this is a tan inverse function? Well, tan x doesn't exist every 180 degrees. It doesn't exist at 90 degrees, and it doesn't exist at 90 degrees, and it doesn't exist at 270 degrees. Does everybody agree that this graph matches that? Alright, so, sorry, just let's go back to the beginning here. So, what's the question you want from me? Write the equation. Look, see this vertical line? The graph was on its way up, wasn't it? Does everybody agree that's 0 to 90? And tan gets bigger from 0 to 90, doesn't it? So, remember ASTC again, okay? Now here's how we know this is it. Okay, is tan positive from A to C? Oh, sorry, from 0 to 90? Tan is positive, isn't it? And what happens to tan values as it gets bigger? Look, tan 30 is 0.57. Tan 60 is 1.73. Tan 89 is an absolutely massive number. Can anybody tell me why tan 89 is an absolute massive number? Tan 89 degrees. So what's tan again? Tan is opposite divided by. If the adjacent is really small and the opposite is just a regular size, what does it mean about that? That red line will divide into that blue line many times, which makes the value of tan absolutely huge. If you write in tan 75 into your calculator, tan 85, tan 89, you'll see that it absolutely explodes in value. So I'll show you again. Start at 0. Start at 75, end at 90. And I'm going to do a step of 1, and you'll see exactly what I'm talking about. Tan 75, no bother. The adjacent divides into the opposite 3 times, 3.75 times. Now go up to 85. Oh, the adjacent will divide into the opposite 11.4 times. This means the opposite is 11.4 times bigger to do an angle of 85 degrees. Now look what happens when you get to 89 degrees. The opposite is 57 times bigger than the adjacent. Does that make sense? Because the opposite's getting really small, because you're getting very close to 90 degrees. You're going straight up, you're nearly going straight up, and the opposite is massive when compared to the adjacent. Does that make sense? Alright, now what happens after you go, what happens when you go to 90 and it's undefined, which means that you're not allowed to cross, there is no point for 90, which means that this straight line here, you'll see no green part. The green line doesn't pass there. But what happens the minute it leaves 90 and goes to 91? What happens there? It's negative, but it's really negative. So look what happens if we do this. Stop at 100, let's say. Step of 1. And you go from 90, which is undefined. And look, 91 is minus 57. So it's gone negative and it's on its way back up to becoming more positive. Because we know that tan is negative in the second quadrant. So from 90 to 180, it's really negative, but it's on its way back up again. Then it eventually hits 0. Okay? Now what happens when it's 0 is that if you look at this, what happens when it's 0 is it swings all the way around. But what actually happens here is that the adjacent is really long, but the opposite, which is this line here, the opposite eventually flattens. And if there's no opposite, what does that mean? So if the opposite side is completely flat, what does that mean? Tan is opposite over adjacent. If the opposite is 0, and it doesn't matter what size the adjacent is, what's tan 180 going to be? 0. Exactly. That's how you see it there. And then it goes to the third quadrant now, which is 180 to 240. And what do we know about 180 to 240? And that's why it's positive again. Is that okay with you guys? Now, sorry, I spent a long time there. So look, for today, there's no need to do 6. Try 7 and 4 part 2 and 7 for tonight, okay?
Sir, do you